Okay, another video where we're going to talk about a method of finding the area under a curve. And this method is particularly well suited to the way computers calculate things, which is just throwing a lot of numbers out there into the world, and using random number generators, which computers are kind of good at. We can talk about how a computer generates a random number maybe separately. So we're going to use the same function we did before, just y equals x squared. And we're going to ask ourselves, what is the area underneath this curve? The last time we did this by dividing this up into a bunch of rectangles and actually calculating those areas. We're going to do something a little different. We're going to just imagine this as a dartboard, and we're going to throw a dart at it. And that dart will land somewhere at random, but within the square. You're not allowed to miss the square. So the interval we're interested in here is from 0 to 1. We'll drop a point into this square, just choosing an x and a y coordinate at random. Okay. There are two possibilities. The dot can be above my curve or below my curve. It's above the curve if the y value is bigger than f of x. In this case, f of x is x squared. So if y is bigger than x squared, it's up here somewhere. If y is less than x squared, it's below the curve. And it's a simple matter of just computing the function and then asking, is my random y that I chose bigger or smaller than the function? And that tells me if I'm above or below the curve. So here, if the point falls above the curve, I'm coloring it red. If it falls below the curve, I'm coloring it blue. And then we just do this over and over and over again. We choose a random point, a random x, a random y. We ask ourselves, is the y bigger than f of x? And my mark, is it above or below the curve? If we do this a bunch of times at random, we can ask ourselves, what is the ratio of points above the curve to below the curve? That'll be related to the ratio of the two areas. Right? The ratio of blue dots to red dots is roughly equal to the area under the curve divided by the area over the curve. Right? It's just the ratio of how many fall into each region is proportional to the area of that region if they're truly random. Put another way, the ratio of blue dots to the total number of dots is approximately equal to the ratio under the curve, the blue area, divided by the total area of the interval, which in this case is just 1 by 1. Okay. So I can get an estimate of how much of this area is below the curve by just throwing random dots in it and measuring the ratio of dots below the curve to the total number of dots. If the interval goes from A to B, we can write this, that the area of A over the area of this rectangle, which is just A times B, is approximately equal to the number of dots under the line, the number of y's less than our function, divided by the total number of points we picked. Okay? And this approximate is not very good if we just do 10, 15, 20 dots. But if we do 10,000 or 15,000 or 15 million dots, this approximate becomes more and more equal because we basically fill up all the available space with dots. This method of finding the area under a curve is called the Monte Carlo method of integration, and it's particularly useful when the function is a really, really complicated function that might not be integrable using the tools of calculus. Those of you who have taken Calculus 2 know a whole bunch of tricks for integrating a whole bunch of functions. But those tricks don't necessarily work for every function. There are functions that are very, very complicated. And so this is a way to compute the area of a function whose integral is too complicated for us to determine numerically. And it's as simple a matter as if we can compute the function, I just stick an x and a y in it, and I ask, is the y bigger than or less than f of x? So this is the idea we're going to turn into code. We're going to choose a function. We'll start with y equals x squared, and maybe we'll make it more complicated over time. We'll learn how to make random numbers in Java. We'll create random x's and y's, and we will ask ourselves, is it over the curve or under curve? And then we'll do this many, 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 many times, and we'll see how close we get to the known value of the integral of that curve. Remember, the known value for the integral of y equals x squared from 0 to 1 is 1/3. So we'll test it with that case, and then maybe we'll look at some more complicated examples or some more complicated functions.